Welcome to our deep dive into NASA's Wallops Flight Facility and its expanding role in supporting sounding rocket launches. Nestled on the eastern shore of Virginia, this modest-looking facility holds an enormous legacy. It's been one of NASA's most consistent and quietly powerful workhorses when it comes to suborbital research. Since its inception in 1945, Wallops has served as a testing ground, a research base, and now more than ever, a launch pad for scientific ambitions that stretch into the edges of space. Wallops Flight Facility was originally established to serve the National Advisory Committee for Aeronautics, or NACA, the predecessor to NASA. Back then, the goal was to conduct high-speed aerodynamic research for military and aviation advancements. But what began as a humble rocket range quickly grew into a hub for cutting-edge space exploration. Over the decades, Wallops has seen more than 16,000 launches, from tiny meteorological rockets to full-scale suborbital missions. The facility offers unmatched access to launch over the Atlantic Ocean, making it perfect for tests that need uninhabited ocean zones underneath the rocket's path. What makes Wallops so special isn't just its history, it's its versatility. Unlike the massive spaceports used for sending spacecraft into orbit, Wallops is optimized for sounding rockets, compact, suborbital rockets that serve a crucial but often overlooked role in space science. These rockets don't reach orbit. Instead, they arc into the upper atmosphere or near space before falling back to Earth. But during their short flight, usually lasting only 5 to 20 minutes, they can gather an enormous amount of data. Sounding rockets are used to explore everything from the composition of the ionosphere to the behavior of particles during solar flares. They can capture data from altitudes unreachable by high-altitude balloons but without the cost or complexity of an orbital launch. Researchers use them to conduct microgravity experiments, test new spacecraft instruments, and even observe astronomical events like solar eclipses without interference from Earth's atmosphere. The beauty of sounding rockets lies in their simplicity and affordability. Compared to a full orbital launch, they're relatively low-cost, quick to prepare, and highly customizable. This makes them perfect for time-sensitive experiments or for trying out new technologies before integrating them into larger missions. NASA often uses them to validate instruments that will later be flown on satellites or interplanetary spacecraft. It's a way to test components in the harsh conditions of space, radiation, vacuum, temperature extremes, without risking an entire satellite. Wallops is at the center of this ecosystem. The facility has its own fabrication shops, integration hangars, and mission control systems tailored for sounding rocket operations. Scientists and engineers can prepare payloads on-site, test them thoroughly, and then roll them straight out to the launch pad. The entire process is streamlined, allowing for high efficiency and quick turnaround times. And Wallops doesn't just serve NASA. The Department of Defense, university researchers, and even international agencies use its services. In November 2023, for instance, Wallops supported the launch of 2 sounding rockets for the DoD. These missions demonstrated not only Wallops' technical capabilities but also its strategic value in supporting national defense objectives. It's becoming clear that the facility is more than just a research center. It's a multi-mission launch complex supporting a wide range of users. What makes Wallops even more impressive is its ability to go mobile. NASA has developed mobile range systems that allow the Wallops team to deploy launch capabilities to remote sites around the world. Whether it's the icy tundras of Alaska, the northern reaches of Norway, or the deserts of Australia, sounding rocket launches can happen where science demands it. These mobile operations include everything from radar tracking systems to telemetry stations, enabling safe and precise launches in almost any environment. This flexibility is crucial for scientific missions that require observing phenomena only visible from certain geographic locations. For instance, studying the auroras requires launches close to the polar regions. Observing solar eclipses often means launching from a narrow strip along the eclipse path. Wallops' mobile capabilities ensure that these opportunities aren't missed. As we move further into the era of commercial spaceflight and deep space exploration, sounding rockets remain as important as ever. They serve as a bridge between laboratory research and full-scale missions, providing an essential testing ground for new ideas. Wallops is also working on advancing the next generation of suborbital vehicles. Engineers are exploring ways to make these rockets more reusable, more reliable, and even capable of higher altitude missions. Beyond hardware, there's also a human aspect to the work at Wallops. The facility plays a critical role in STEM education and workforce development. Every year, student teams from across the United States design and launch experiments on sounding rockets under NASA's RockSat and CubeSat programs. These hands-on experiences prepare the next generation of scientists, engineers, and mission planners, giving them a direct connection to real space missions. Wallops is also helping to push forward the boundaries of public-private collaboration. The facility works closely with commercial partners to develop new payloads, refine launch processes, and share infrastructure. This partnership model is key to the future of space access, ensuring that government and industry can grow together. As commercial demand for suborbital testing increases, Wallops is poised to meet that need. And let's not forget the international aspect. Wallops has been working with agencies like the European Space Agency and the Japan Aerospace Exploration Agency to support their sounding rocket needs. These collaborations are more than just shared resources. They represent a global scientific community working together to unlock the mysteries of Earth's upper atmosphere and near-space environments. In an increasingly interconnected world, Wallops stands as a model for how nations can cooperate in the pursuit of knowledge. Even regulatory milestones are being met. The FAA has recognized and approved Wallops' expanded role in supporting diverse launch activities. This includes licensing for launches that fall outside traditional profiles, enabling greater flexibility for experimental and commercial missions alike. This regulatory backing is essential in streamlining operations and reducing bureaucratic delays that often hinder innovation. Looking ahead, the role of Wallops in NASA's broader strategy is set to grow. As missions to the Moon, Mars, and beyond become more frequent, the need for robust testing platforms will only increase. Sounding rockets offer the perfect proving ground, and Wallops is uniquely positioned to support that demand. From evaluating life support systems to testing advanced communication arrays, the work done at Wallops paves the way for future crewed and uncrewed missions. In many ways, Wallops represents the heart of NASA's pragmatic approach to innovation. It's not the flashiest facility, and it doesn't make headlines the way Kennedy Space Center or Johnson Space Center might. But it's here, in this coastal corner of Virginia, that many of NASA's big ideas are born, tested, and validated. It's where science becomes engineering and engineering becomes flight. From its legacy in early rocketry to its future supporting both scientific and commercial ventures, Wallops continues to play an irreplaceable role. And with each sounding rocket that lifts off from its pads, be it for a student experiment or a national defense test, Wallops reinforces its position as a launch site where innovation meets altitude. As we delve even deeper into NASA Wallops Flight Facility's evolving role, it's impossible to ignore how it's quietly becoming one of the most strategic assets in America's space infrastructure. While most people associate space launches with flashy orbital missions or Mars rovers, the work happening at Wallops is no less groundbreaking. Here, research rockets are unlocking the secrets of Earth's upper atmosphere, advancing propulsion systems, and even laying the groundwork for next-generation planetary missions. It's the kind of behind-the-scenes work that doesn't always make headlines but directly fuels the future of space exploration on every level. In recent months, Wallops has seen a surge in new investments, both financially and technologically. NASA has been upgrading key launch pads, expanding payload integration facilities, and even developing new environmental testing chambers. These enhancements ensure that Wallops can support a wider variety of missions, from lightweight high-altitude probes to heavier scientific instruments designed for more complex experiments. This infrastructural growth also means faster turnaround times between launches, which is critical when responding to unpredictable phenomena like solar storms or geomagnetic shifts that can't be studied from ground level alone. And it's not just about launching rockets, it's also about what happens after the payloads return. Recovery and post-mission analysis at Wallops are entering a new era with advanced telemetry systems, machine vision tracking, and autonomous data relay. Engineers are now able to retrieve critical information even before the payload touches down. This shift minimizes data loss and increases the accuracy of scientific findings. It also sets the stage for future missions where human involvement may be limited, such as robotic lunar outposts or deep space probes needing real-time ground support. Wallops has also become a proving ground for novel materials and aerospace engineering concepts. Recent launches have tested ultra-lightweight composites and temperature-resistant alloys intended for long-duration space travel. These materials are crucial for future missions to the Moon, Mars, and even asteroid belts, where traditional equipment may not withstand harsh environmental conditions. By sending these components into space via sounding rockets, NASA can validate their performance quickly and inexpensively, an essential step before full-scale deployment on interplanetary missions. Another frontier opening at Wallops is high-speed data communication. Sounding rockets launched here are now being fitted with experimental optical data links, allowing them to transmit massive volumes of information through laser-based systems rather than traditional radio waves. This technology could revolutionize how we receive data from spacecraft, enabling real-time video and detailed sensor readouts even from remote regions of Earth's upper atmosphere. The potential applications extend well beyond science, into national security, aviation, and disaster response, where rapid and reliable data transfer is paramount. One underappreciated but vital role of Wallops is planetary defense. As concern grows about potentially hazardous near-Earth objects, NASA is developing methods to detect, track, and possibly deflect these space rocks. Wallops has supported missions that test sensors capable of identifying these objects early, often simulating their movement and behavior through sophisticated modeling and suborbital test flights. This proactive approach ensures humanity is better prepared for any future celestial threats and keeps Earth safer through rigorous science-based planning. Then there's the human side of all this work, the scientists, engineers, and students who bring these missions to life. Wallops fosters a highly inclusive and collaborative environment. Many of the teams working here are international, bringing together diverse perspectives that lead to richer innovation. For instance, a recent collaborative mission included participants from Japan, Norway, and Canada, each contributing unique instruments and research goals. This spirit of international partnership not only enriches the science but also strengthens global cooperation in space, which is more important now than ever. The environmental responsibility at Wallops is also worth highlighting. As launch frequency increases, NASA has committed to minimizing ecological impact. The facility has adopted sustainable practices such as green propellants and low-emission generators, and continues to monitor local wildlife, including sensitive species like sea turtles and migratory birds. Environmental impact assessments are integrated into every new project, ensuring that space exploration does not come at the cost of Earth's delicate ecosystems. This balance between progress and preservation sets a strong example for spaceports worldwide. And perhaps one of the most inspiring aspects of Wallops is its connection to the community. The facility isn't an isolated government outpost, it's an integral part of the region. Locals take pride in watching rockets ascend from their nearby beaches. School programs regularly visit the facility for hands-on STEM education. Outreach efforts include public viewing areas, guided tours, and even citizen science initiatives where volunteers assist with data collection and wildlife tracking. This level of public engagement creates a sense of ownership and excitement around space exploration that's rare and deeply valuable. Looking toward the future, NASA has ambitious plans to integrate Wallops more closely with its Artemis program. As we return to the Moon and look toward Mars, Wallops will serve as a vital support node, testing communication systems, verifying onboard sensors, and simulating emergency scenarios and controlled suborbital flights. These missions are essential dress rehearsals for crewed interplanetary journeys. And because Wallops can launch quickly and adapt to mission changes, it serves as a flexible testing bed in the dynamic landscape of spaceflight development. Even commercial space companies are taking notice. Firms like Rocket Lab have begun launching missions from Wallops, drawn by its advanced infrastructure and proximity to NASA's engineering support. These collaborations signify a broader shift toward public-private partnerships in space, where government agencies and private innovators work hand-in-hand to advance science and technology. Wallops is at the forefront of this transition, helping to open space to more players while maintaining rigorous safety and mission standards. In conclusion, Wallops Flight Facility isn't just a place where rockets launch, it's a symbol of ingenuity, collaboration, and relentless progress. From tiny atmospheric probes to cutting-edge propulsion tests, every mission that begins here adds another piece to the puzzle of our universe. And as new challenges emerge, be they environmental, technical, or geopolitical, Wallops stands ready to adapt, lead, and inspire. So the next time you hear about a sounding rocket or see a small blip on the radar from coastal Virginia, remember what it represents. It's not just another launch. It's a bold step toward understanding our planet, protecting our future, and exploring the stars. NASA Wallops isn't just supporting rocket science, it's shaping the destiny of space exploration one launch at a time.